to target 29, completing the square, hard version, standard form, and a graphing form. You'll notice that this is still in standard form at that ax squared plus bx plus c kind of deal. We're going to be converting it to this where y equals a times x minus h quantity squared plus k. So we're still doing that. But what makes these challenging or different is this 3 right here. We have a leading number. We have a leading number. Well, don't freak out about it because all we need to do is get that leading number out of there for a while, then do our half and our squared, and then we have a little additional thing that we're subtracting. It's got to be times 3 larger in this case, and that will give us the 3. So we're still going to be following the same process of half, the middle number, square it, and subtracting from the end, but the only difference is we have to make sure that we keep track of the actual 3 and what it does. So let's see what the 3 does. The 3 is going to end up being our number that goes here in front of the, as the a value. So we're going to go y equals, take the 3 out of these first two pieces. We need to divide this by 3 and this by 3 because those are the ones with the x's in them. So divide the 3 out and you'd have x squared minus 4x, and the plus 10 is just still going to sit on the end. It's kind of a loner. It just sits over there. It doesn't have an x. So I divided this by 3 and I divided that by 3. Now I'm going to do the half square subtract. So watch. The 3 is going to go here. I'm going to go x minus 2. So I'm still doing half of the middle number, and it's going to get squared. But what's interesting is last time we just do 2 squared and subtract it from here. 2 squared is 4. Well, we can't do that because it's got to be 3 times larger. So we need to figure out 3 times 2 squared. So I need to know the answer of 3 times 2 to the second power. That's actually what I'm subtracting. That's where the 3 plays an additional role. So the two things you have to do for an adjustment are 1, divide the 3 out of the first two terms that have the x's in them. And then when you do your subtraction, you do 2 squared is 4 times 3 is 12. I'm actually subtracting 12. And the reason why I'm doing that is because it has to be 3 times larger of my half squared. And then I end up with 10 minus 12, which would be minus 2. And now I've got it in graphing form, and it's right here is my final answer. You can type this equation in your calculator, and you can type the original equation in your calculator and push second table to confirm that they are exactly a match. So let's take a look at the process again. We're still doing half, square, subtract, but the issue is we got to get the 2 out. So take the 2 out of the first two terms that have the x's in them. Leave that last number on there. It's kind of a loner. You just put it on there because it doesn't have any x's in it. So we take the 2 out, and then we do the half square subtract trick. So we do this, and we do half of it. Half of 4 is 2, and it's going to get squared. But before we can just subtract 2 squared, we got to remember we have a multiplier, a 2 that we need to deal with. So 2 squared is 4, times 2 is 8. I'm subtracting 8, and I actually get negative 18. Negative 10 minus 8 is negative 18, and there is my full equation right there. Now again, ladies and gentlemen, you can type in this one, you can type in that equation in your calculator, you can type that equation in your calculator, you can push second table, and you can see that are going to show you the exact same tables. That's one easy way to confirm that you did it right. If you want to take a look at that, we can do that right now. We can just type them in. So I go y equals, and I go 2x squared plus 8x minus 10, and the other one had a 2 on the outside of parentheses with an x plus 2 inside the parentheses squared, and then minus 18, and I go second table, and boom, the numbers match. So no matter where you are on this table, all of those numbers are exactly the same. Therefore, it proves that we did it right. It's an easy way to check your answer.